Drink! I'm up! Please do not tell me you fell asleep in here yesterday. No, I was just, working on a chemistry project, obviously. I just wanted to rest for a bit, that's it. You doing work? That's hard to believe. Actually, since you're my friend, I should help you with this so-called project. I mean, you don't have to do all of that. No, this isn't a suggestion, Drayton. Your grade is at stake. I'll even let you use my notepad to take notes. So, what's this project about? Solubility.
Oh, really now? Well then, this should be an easy explanation, and I hope you listen.
This room doesn't even have a projector. Why do you have that?
The most basic things to talk about in a way you would understand would probably be the factors of solubility. So let's start with temperature.
The only thing I know about temperature is that Septile hates it cold and the polar biome is very cold.
Exactly why we're doing this. So the temperature works in tandem with the kinetic energy when it comes to solubility of gases specifically, as when the temperature increases, as will the kinetic energy of the gas particles. Because of this, the gas particles have a greater molecular motion, and the particles already dissolved by the water will become more likely to escape and revert to the gas phase, and existing gas particles would be less likely to dissolve.
Oh, so how about when it's cold?
The opposite happens, so the trend to follow would be simple to remember. Higher temperatures would mean decreased solubility, and lower temperature would be increased solubility.
Alright, so is that the same with solids?
No!
Why are you here?
Amaris called me because she knew I had the highest chemistry grade among all of us. Did you? He takes the same chemistry course as you, correct? So he should be focusing on the same things you should have focused on your first year of taking that class. And your second. And your third.
Okay, shut up.
Okay. Crispin, care to explain how temperature affects solids with solubility? Right, so temperature's effects actually differ depending on if the reaction is endothermic or exothermic. Endothermic being the absorbing of heat from the surrounding objects, and exo being the release of it, and yada yada.
Okay.
Yeah, so for an endothermic reaction, increasing the temperature causes a stress on the solute due to the additional heat. So the solute leans more into the solution, which then causes increased solubility.
And let me guess, exothermic causes a stress on the solution, so then it goes more into the solute, then causing decreased solubility?
Yeah.
Oh, for real?
You actually got that right based on background info. Proud of you.
Oh, I'm actually listening. That's weird.
Yeah, anyways, next. So, agitation. That's like stirring and shaking the solution, by the way. So when a solute is agitated, the process of dissolving is accelerated, so in simple terms, it just speeds up the process. When it comes to the solids and gases, agitation kind of affects it in the same way. The only exception would be stuff like carbon and soda. Oh yes, when soda is shaken, some of the carbon dioxide will be released from the solution, thus the fizzing. But that also means that carbon dioxide will dissolve back into the soda when it becomes stable once again.
Okay, so what you're saying is agitating the soda would speed up the CO2 escaping from the soda, but it also helps dissolve it back into the soda when it's all clear from excess gas?
Exactly! I'm beginning to wonder why you're failing. You're actually quite quick at picking things up.
I don't want to pick up pencils.
Oh. Anyways, pressure! Pressure doesn't actually affect the solubility of solids, only gases. Pressure is kind of weird. The gases just get squeezed into the solute and boom. What he's saying is that molecules will collide more frequently with the surface of the solute due to an increase in pressure. As more collide with the solute surface, they squeeze between the molecules of the solute and become a part of it.
So when there's less pressure, the gas molecules come out, so it's just another soda analogy?
Ah, yes, carbonated beverages are pressurized for that reason. It'll keep it tasting fresh.
I could really go for a soda right now.
Well, that can wait because we planned one more topic to explain to you.
Of course you did.
Surface area. So when surface area of a solute is increased, the solute should dissolve more rapidly. Surface area is increased when the solute is broken into smaller pieces, thus why sugar packets dissolve quicker than if you just put a sugar cube.
Oh, so that's where the agitation would come in, right?
Exactly. Seriously, Drayton, you're good at this stuff. You gotta actually work on your schoolwork.
Wow, your grandpa might not give your inheritance to your sister if you keep that up.
Kieran, don't be so distasteful.
Why are you all here at 6 in the frickin' morning?